Chapter 2 students. We've got another exciting episode of math learning for you. This one, Chapter 2.9, Combined and Joint Variation. So, when direct and inverse variations occur together, then that situation is called a combined variation. So we've learned about direct variation, either y equal kx or y equal kx squared. And we learned about inverse variation, which is y equal k over x or y equal k over x squared. And the idea is if we have both of those happening in the same example, that's going to be the combined variation. So let's take a look at that. For this example, we're going to look at the time that it takes for a parade, like a marching parade with floats, that kind of thing, or like the parade that you guys put together for sports day, that kind of thing. So we look at the time that it takes for that parade to pass the judging booth, right? So it's sports day, you're doing your parade with the costumes and all the props and that kind of thing, and you're going by the judges' stand to get judged for your first, second, third, and fourth place. So the time that it takes to do that is going to vary directly as the length of the parade, because as the parade is longer, it's going to increase the time to go by the judge's stand, but inversely as the speed of you guys marching or walking in your parade. So inverse because as you increase the speed of you guys walking in the parade, the increase of speed is going to decrease the time that it takes to go by the judge's stand. Okay, so we have direct and inverse variation going on, so this is going to be a combined variation. Can we write the general equation to model this situation? All right, go ahead and pause and try and come up with it, and then you can check and see if you got it right. Okay, so we're looking at the time. That's one of the things that's changing, so we just call it the variable t. Varies directly as the length of the parade. So that's one thing that we could change, the length of the parade. We'll call that L. And then inversely for the speed of the parade. So we'll call that S. So then we have t equals, well, it's direct variation with the length, so it's k times L, but it's inverse to the speed, so I have to put over S, put the speed in the bottom, and that is going to be our equation of variation. And again, it's a combined variation because the L is in direct variation, but the S is in inverse variation. Okay, so one other thing to look at is the idea of joint variation. And all joint variation is the case where you have direct variation, but the thing that we're looking at, the output, it varies directly as the product of two or more inputs. So basically, if I have 2, 3, 4, or even more than that variables, and if as I increase each of those, my output increases, then all that together is going to be considered a joint variation. I think it'll make more sense once I do a example here. But again, to summarize, if a quantity varies directly as a product or a multiplication of two or more variables, that's called the joint variation. So let's look at an example to try and make this more clear. So I have y equal to k times x times z. This is a joint variation because we can assume k is the constant, but y still varies directly as x and z. And so since x and z is a multiplication or a product, it's called the joint variation. Okay, let's look at this in a application problem. So the wind force, the force of the wind on a vertical surface varies jointly as the area of the surface. Because if you think about it, as you increase the area of the surface, the more force that the wind is going to exert on it. and also as the square of the wind speed, because as the wind moves faster, then the more force, again, is exerted on the surface. So it varies jointly as the area of the surface and the square of the wind speed. And then we are told that the force is 340 newtons on a vertical surface. So our force is 340 newtons on a vertical surface with area of, so the area of the surface is going to be 1 square meter. And we know that the wind blows, that happens when the wind blows at 18 meters per second. Okay, and we need to find the force. Our question we have to answer is, we have to find the force exerted by a wind of 35 meters per second. So there's our wind speed, 35 meters per second. And on a vertical surface, where the area of that surface is 2 meters squared. So the vertical surface area is 2 meters squared. Okay. So first thing we're going to want to do is we're going to want to write our variation equation. So the wind force, that's going to change, we call it F, varies jointly. So that tells us that everything that comes after this is going to be multiplied together, basically, times the constant of variation, and that's going to equal our output, in this case, wind force. So wind force varies jointly as the area, so we'll call that A, and the square of the wind speed, so we'll call that W squared. So how do I write that as an equation? Well, wind force varies jointly, so F equals K, and then it's jointly, so I know I'm just going to multiply a bunch of things together. K times the area times the wind speed squared. So it's K times A times W squared. Okay, now think about what your next step would be to find the force exerted by the wind of 35 meters and area of 2. Well, yeah, we could plug the wind and area in, but we still need the K in order to finish this. So we can get the K because we have the force, the area, and the wind for one situation. So we have all three of those in one scenario. So we can use that. So the wind force of 340 newtons is equal to K times the area is 1 and the wind speed is 18, but it's the wind speed squared, so it's 18 squared. And so I get 340 equals K. Okay, well, 18 squared, I'm going to use my calculator for that. It's 324. So then I just divide by 324. So K, our constant of variation, is 340 divided by 324, which is just a little bit over 1.05. All right, now that we have our K, our model or our equation is done, meaning just give me an area and a wind speed and I can tell you what the wind force is going to be. So let's go ahead and find the answer to our question, which is find the force when the wind speed is 35 meters per second and the vertical surface is 2 meters squared. So we just plug in 35 goes in for the wind speed and 2 goes in for the area, and we can just put it all in our calculator to find the force. So we get force equals 1.05 times the area is 2. So we'll put in 2 for the area. The wind speed is 35, so it's going to be times 35 squared. And I just multiply that all into my calculator, and I get a force of roughly 2,572.5 newtons. And that is going to wrap up this lesson. Thank you very much. I'll see you in the next class.